Hello, it's Waffles2 here again. Still experimenting with aerospace planes. The Aurora is a really nice plane, but I thought I'd try mixing it up a bit. This is a slightly different one called the Piper. It's got a maximized wing area, a really low wing loading, and I switched out the engines. Instead of two turbofans in one aerospike, it's one turbofan and two aerospikes. And it's interesting to note how small changes like that can really change the aircraft's launch profile. Anyway, let's put this thing in the air, shall we? As soon as the brakes let go, we'll throttle the engines up, and there they go. All right. First thing, this thing's got just an absolutely under the turbofan engine. It's got an absolutely anemic thrust-to-weight ratio. So this thing is not going to accelerate down the runway like the Aurora does. But what this thing can do, what the Aurora can't, is take off at under 100 meters per second. Yeah, we're already airborne. Didn't even hit the end of the runway. Now the downside of this is we can't force this plane to really climb faster than about 10 meters per second. It's going to be a while to get up to launch altitude. So I'll probably edit most of that part out, tune back in when we're about to light off the aerospikes. I'll see everyone in a minute. What's that? Well, I'm going to do a jump out of here. Welcome back, and here we are 15 kilometers up, and for this spacecraft, basically right on the edge of space. Now we're watching our intake air here, because that's going to determine when we need to fire the aerospikes. When that hits 110, we're starting to risk a flame out. We're going to fire off the rocket engines, build some speed, and get more air going into the engine. I think we can get a few more kilometers up before that happens. But yeah, this plane's where's the? I'll show you some stupid Aurora tricks later, but where the Aurora can just power up to high altitude and use its jet engines basically to start its orbital descent. The Piper is a slow, steady climb up to a high altitude, and well, just for fun, watch the speedometer and the G-force meter down by the nav ball as soon as I light off these rockets. Alright? I get a kick out of this almost every time, just thinking about what these numbers mean. And, yeah, we're accelerating at about 3 Gs, nearly straight up. This is going to be a very fast descent from here. You hear the engines screaming. kilometers up. We'll coast up and circularize. Well, okay, they gobble fuel at an ungodly rate when compared to the jet engines. Pump that back up. That tiny, tiny little bit of drag left at this altitude. There we go. Now, everything else standard. Map view. Find our Apple apps. Add the maneuver node. And circularize. It's a fine hand sometimes. Yeah, for Pete's sakes. Anyway, I think that'll be good enough. Yeah, good enough. It'll keep us out of the atmosphere, and I don't have a lot of time to dink around either. You can see our maneuver node is coming up fast. Three seconds of burn is all it's going to take to finish putting this bird into orbit. But you saw how you saw how fast that ascent was. I mean, here we are circularizing. The Aurora would get it in the upper atmosphere and burn and burn and burn and burn and burn. This thing does the upper atmosphere stuff very quickly, but it also means your mistakes are big and costly in terms of fuel. Now, I've got a flight recorder installed from the Flight Engineer pack. That gives you a lot of useful information about your ship, rendezvous, surface speeds, but I'm using it mostly for instrumentation on my orbit. Bad circularization, but it's out of the atmosphere and therefore stable. Oh well, practice makes perfect. Anyway, here we are in orbit. Not a lot of fuel left. I'm still, like I said, I'm still trying to figure out a more efficient flight or ascent on this plane, and it simply may be beyond its capability. It just simply may not be as efficient as the Aurora, in that it depends largely on these rockets to get into orbit instead of its jets, like the Aurora does. You remember the Aurora? We're usually hitting 1.1 to 1.2 kilometers per second before we even light the rocket motor. Anyway, this is fun. Let's go ahead and get set up for our deorbit burn. And then I'll show you how it lands, and it'd be just my luck I'd crack it up on the runway too, showing off my nice new bird and scatter it across 3 time zones. That should do. Kerbin's going to rotate, so we'll anticipate it a little bit. All right. And let's do that orbit thing. I'll see everyone on the other side.